So let's work on the examples in the book. But before we do that, let us recall your fundamental theorem of calculus part 1. What did it say? The requirements were you need to have a function that's a small f of x that is continuous on the closed interval ab. And you also need to have another function, big F of x, which is equal to the definite integral from a to x of f of t dt. Now, when these two conditions are satisfied, they together imply that the first derivative of big F of x is simply equal to f of x, or the small f of x. So for this case, we have g of x equal to the definite integral of 1 over t cubed plus 1 dt from 1 to x. So this corresponds to our f of x. And 1 over t cubed plus 1 corresponds to our f, small f of t. So so f prime of x is equal to g prime of x. Basically, f prime of x is g prime of x, and this should be equal to f, small f of x, which is 1 over t cubed, 1 over x cubed plus 1. So the same thing with g of r. G of r. So g is a function of r. So this is our big F, but we're not using x, we're using r. And square root of x squared. So this, in this case, our x corresponds to t in the original formula. So this one, the square root of x squared plus 4 is small f of, instead of t, small f of x. So in this case, the fundamental theorem of calculus says that f prime of r is equal to small f of x. Our f prime of r is g prime of r, and f of x is square root of x squared plus 4. So this is it. Okay, so the next example is not as easy as the previous examples because the upper bound is a function. It is a function of x. So that's why we have the chain rule. Again, what is the chain rule? So suppose we have a function that is a function of another function. So we have a composite function, f of u of x. When we want to get the derivative of big F of u of x, then we'll have to use the chain rule because we have an inner function. So this is like, if you take the derivative of f first with respect to u, and then you take the derivative of u with respect to x. Or simply you say the derivative of f with respect to u times the derivative of u with respect to x. So that is the chain rule. Now, why do we need this here? Okay, so for example, let's say let g of x be a differentiable function. And let g prime of x be f of x. So suppose, so it follows that the antiderivative of f of x is g of x, meaning g of x is equal to the integral of f of x dx. So something like that. Okay, this is with respect to some constants. So now, when we derive this, so basically, if I have g of x equal to, let's say, the integral, definite integral from a to u of x of f of t dt. Okay, if I take the derivative of both sides with respect to x, now what would happen? This would become g prime of x, and then this would be, okay, first things first, what is the antiderivative of f? It is g, right? So this one would be g of t from a to u of x, or from a to u, and this is equal to g of u of x minus g of a. So we can distribute this. This is g of u of x minus the derivative of g of a. Now g of a is a constant, so the derivative of this is 0. Okay, so the derivative of that is 0. For this case, we have a composite function, g of u of x. When you take the derivative of g of u of x, then you'll have g prime of u of x times u prime of x. Okay, so what is g prime of u of x? G prime of u of x is g prime of x is f of x. So g prime of u of x is f of u of x times du over dx. So this is g prime of x. So this is what we're gonna use here. Okay, so that's why from the beginning we have g of x is equal to the integral from a to u of x of f of t dt. So for our case, we have this. F of x is equal to the integral from 1 to u of x of sine t dt. So sine t is our f of t. So to take the derivative of this, so we follow this. So we have f prime of x, okay, so that corresponds to our g prime of x, equals f of u of x. So small f of u of x. So we have sine t, but we have to replace t with u of x. So it will become sine of u of x times du over dx. So what we have is sine of u of x, du over dx. What is du over dx? Du over dx is the derivative with respect to x of square root of x, or x raised to 1/2. What's the derivative of x raised to 1/2? That's 1/2 x raised to negative 1/2, or 1 over 2 x raised to 1/2, or 1 over 2 square root of x. Okay, so sine of u of x, this is 1/2 times x raised to negative 1/2, or this is just 1 over 2 square root of x. So sine of u of x, you replaced u of x with its defined form, so the square root of u. So sine of square root of u of x over this is 2 times square root of x. So therefore, f prime of x is sine square root of x over 2 square root of x. Okay? So we'll just do the same thing here. I'll just use a different color. So for this case, this will be our u. So let u be x cubed. Well, basically, du over dx is 3x squared. F of t is cosine of t. So it follows that what? F prime of x, big F prime of x is equal to cosine of u times du over dx, which is equal to, what is cosine of u? U is x cubed, du over dx is 3x squared. So we have big F prime of x equal to, okay, so therefore big F prime of x is equal to 3x squared cosine of x cubed.